Welcome back, Syracuse Math Kitties. This is video 3 of Module 5, the review of linear equations. In this lesson, topic 3, we are classifying the number of solutions as all, one, or none. As always, we have an explanation here or sample problems that we're going to go through before we tackle the assigned problems. I would make sure that I understand this. If I don't understand it, I'm going to reread it again and then make a second attempt. And then even if you still don't understand how to do it after that, then of course you're going to reach out to Ms. Piraino or to myself, and we will gladly help you. All right, so let's read through the explanation here. So the goal is to classify these equations down here as having all solutions, one or none. Okay, and the way we do that is like this. An equation is a statement that two expressions have an equal value. The equation, for example, For example, equation 2x equals to 6 is true statement if x is equals to 3. If x is equal to 3, we're going to substitute that 3 for the x. So then we have 2 times 3 is equal to 6. Well, that is actually correct because 2 times 3 is 6. So this particular equation has one solution. Okay, why do we know it's one? Well, if we kind of go through, if we go further, we know that this equation is false if x is 4. I mean, you could have put any other number in there. You could have put 5 and you would have still gotten the same answer. So if you put 4 for x, so 2 times 4 is 8. It's not 6. All right, so this equation is not true for values that are not 3. The only value that this equation is correct for is 3. Okay, so the equation 2x equals to 6 has one and only one solution because only one number, 3, that you can double to get 6. Now, you have some other equations that are true no matter what the value of the variable is. For example, 2x equals to x plus x is one such equation. Because if you double a number, double meaning you multiply by 2, that will always give you the same result as adding the number to itself. So equations like 2x equals x plus x have infinite number of solutions, or these equations are true for all values of x. Again, we are classifying each equation according to the number of solutions as all, one, or none. Okay? And then third example is an equation that has no solution. So for example, equation x equals x plus 1 has no solutions because no matter what value x is, okay, it will never equal to, x plus another number, plus 1 more than itself. Okay, so how does this really look like? Okay, so this one has none, has no values of x, will make this equation true. So how do we work through this? Well, basically all you're doing is you are going to try to solve for y. You're going to isolate the variable on one side and everything else on the other side, and then you will see how it basically works out. So let me work through one of these so you guys can see what I mean. I'm going to multiply this through. Okay, so 7 times 2 is 14, and 7 times 5 is 35. Okay, so we have on the left-hand side of the equation, we have 14 plus 35v equals to 3v plus 14. I want to get the v, or the variable, by itself. So I am going to subtract 14 from both sides. Okay, so this 14 cancels out. I'm going to use a different color now. So I have 35v left on the left-hand side. and these 14s also cancel, and I'm going to have 3v on the right hand side. Okay, now if I move this v on the left hand side, I'm going to have negative 3v. I'm going to end up having, I'm going to continue this problem on the right hand side. I'm going to have 32v is equal to 0. Well, this just makes no sense, because no matter what we substitute for v, well, actually this equation is true for one value of v, which is 0, right? So if v is 0, okay, then this equation will be true, because 32 times 0 is actually 0. So 0 is equal to 0. All right, so the only value of v that this equation will be true for is 0. So I guess this equation does have one solution. All right, and if you actually even go back in, okay, and if you substitute, okay, 0 for v up here, and up here, what you're going to end up having is, let's see, you're going to end up having 14 equal to 14, which is a true statement. Okay, so if you see right here, you're going to substitute a 0 here and a 0 here, and you're going to have 14 is equal to 14. So that would be a true statement. Okay, and I don't know why this keeps doing this. Hold up. Okay, how about another one? Okay, how about this one right here? Okay, let me do that in a different color. So let us multiply this through. So we have negative 2v. Negative 2 times negative 2 is positive 4, is equal to negative 3, negative 2v. Okay, I'm going to get the variables on one side. So I'm going to add the 2v, add the 2v. What happens there is that these cancel and these cancel, because negative 2v plus 2v is 0. So we only have left 4 equals to negative 3. And we know that that is not a true statement. Okay, so this equation has no solutions. Okay, that's how you would do that. Okay, how about another one? Okay, let me see, which one should we do? How about, let's do f. Okay, we have more, I have more space for this one. So I'm going to multiply everything through. 3 plus 5n is equal to 5n plus 10 minus 7. So 3 plus 5n is equal to 5n plus 3. Okay, do you guys see what's happening here? Right away, quickly, you can see that these two sides are exactly the same. Okay, but we can go further. Already at this point, we know that this equation is true for all values of v, but we can go ahead and multiply it out if you want. Okay, but basically anything you substitute here, it's always going to be the same on both ends. Okay, so you guys can do that for all of them. Okay, you work through, basically you work through these, you isolate your variable on one side and the other numbers on the other side, and you see whether or not it is it can have one solution, none or all. Okay, so there you go, that would be it. Wait for video number 4, and we're gonna go through this module real quick. All right, thank you.